Number 7 from the Chapter 5 homework. This problem reads that at the end of this month, Les will start saving $150 a month for retirement through his company's retirement plan. His employer will contribute an additional 50 cents for every dollar that he saves. He's employed by his firm for 30 more years and earns an average of 10.5% interest on his retirement savings. How much will Les have in his retirement account 30 years from now? Okay. This problem is similar to the ones that we've done previous to this, where we've got a series of payments that now we're going to calculate the future value of rather than the present value. But it throws a couple of wrinkles at us that we've got to pay attention to. Okay? The first is that he's going to pay $150 per month. Okay? This is the first problem we've done where we're going to have monthly payments rather than annually. Okay? But the interest rate that it has given us is he earns an average of 10.5% on his retirement savings. Okay, anytime you see a reported interest rate there, unless it tells you otherwise, it's always an annual rate. Always an annual rate. Okay? And I don't think any of these problems tell you otherwise. So anytime you see a quoted rate, it's always going to be the annual rate. So we've got a mismatch. We're making monthly payments, but we're given an annual rate. So we're going to have to deal with that. That's the first wrinkle. The second thing is that the payment is not just $150 a month. His employer is also contributing an additional 50 cents for every dollar that he saves. So when he makes a $150 payment, the employer matches half again as much. Right? So they're going to give him another $75. So we've got to account for that as well. So what we want to know is if he does this for 30 years, makes a $150 payment into his retirement account, and his employer puts in another half again as much, another 75. How much is he going to have 30 years from now as he accumulates 10.5% interest per year? Okay, so let's set our timeline up and look at what we're looking at here. Today is time period 0. The problem tells us that Les will start saving $150 a month through his retirement plan at the end of this month. Right, so not today, but 1 month from now. So this first tick mark here is the end of the first month now. Again, this is the first problem that we've dealt with monthly payments instead of annually. So our tick marks, everything still works here, we just converted to months. So this first tick mark is the end of month 1. He deposits $150, and his employer gives him 50 cents for every dollar that he puts in. So the way we would calculate that is to say the 150 that he put in times 0.5, they're giving him half again as much, is another $75. Okay, so the 150 that he put in plus the $75 that his employee gave him equals a total payment of $225. Right? So the total amount that's going into his retirement account every month is $225, not just the 150 that he put in. Okay, at the end of month 2 here, our second tick mark, the same thing happens. $225 goes in, his 150 plus the employer's 75. We'll go out to the end of month 3, same $225 goes in. And these dots here mean that this happens every month for 30 years. Right? So we go out to month 360. And the way I know that it's the last month is month 360 is I took 12 months per year times 30 years. Okay, so this gives me the total number of months this is going to occur over. So 12 times 30 is 360. And what I want to know is after all of these payments are made over the 360 months, what is the future value after we've compounded interest? Okay, so let's plug this stuff into our calculator. Okay, let me clear out the previous problem. So let's second clear TVM. And I'm going to type in my N. Now we're switching to months here. Right? So our period's in months. Our N is always going to be the total number of payments made or the total number of periods in the problem that we're considering. Okay, if the problem gives us information in months, we're going to enter it in months. If the problem's in years, we're going to enter the number of years. For this one, we're making monthly payments, so we have to enter in the number of months. Okay, so N equals 12 times 30, which is 360. So 360 in N. Now our interest rate, this is where things get a little interesting. There are 2 ways we can deal with this. I'm going to show you the way I always do it, although it may seem confusing, more confusing up front. It'll save you a lot of headaches later. Okay. I'm going to choose to leave my payments per year set to 1. In reality, we're making 12 payments per year. Okay, that's what the P over Y stands for. Okay, I'm going to leave it set to 1 because if I change it for this problem, I will forget to go and change it for another problem. When I go back to an annual problem, I'll leave my P over Y set to 12 and it'll give me a wrong answer. Okay, and it may not be wrong enough for me to realize it. So I always, no matter what problem I'm calculating, I leave my P over Y set to 1. Okay? The adjustment we can make is with the interest rate. Okay, we're making monthly payments, so we need to force monthly compounding onto this. So what I'm going to do is take the 10.5 and divide it by 12. Okay, and that gives me the monthly interest rate based on the annual rate. So I'm going to take 10.5 divided by 12 and hit equals. Okay, so I can see the monthly rate now is 0.875. Okay, it's important that everything matches. If you're making monthly payments, you have to find a monthly rate. Okay, and you're almost always going to be given an annual rate. Okay, so remember to make that adjustment if you see in the problem we're making monthly payments. And so once I've got that 0.875, I can hit I over Y, and it stores that for my interest rate. And that's my interest rate per month. Okay, present value is 0, so I'm going to hit 0 in PV. He's not making any payments today. In my payment here, I've written a shorthand. I've done the exact same thing that I did on the timeline up here. I've just mathematically done it in a shorter way. I've done the 150 times 1.5 rather than doing 150 plus 150 times 0.5 equals 225. This is just a shorter way to do the same thing. Okay, so there's my 225. And again, my default is to look at things from my perspective. So I'm paying out of my pocket the 225, out of my pocket and my employer's pocket, I guess. Combined 225. So I'm going to record that as a negative. So 225 and then minus. Record that as my payment. And then the future value is the one thing we don't know. So that's what we're going to solve for here. We're going to hit compute future value. Okay, and what we see is there's $566,190.22 sitting in our retirement account at the end of 30 years. Not too bad for putting $150 a month in.